Hi, everybody. We're going to learn how to do the worksheet that says significant digits practice problems on it. And I gave you also another worksheet that says rules for determining significant digits. And first thing you have to do is understand what we use significant digits for, especially in engineering. If I gave you just a random number here, let me see if I can get my pen working. There we go. And I said it was 2 centimeters. Or I gave you a number that was 2.000 centimeters. Those two numbers mean very different things in engineering. 2 centimeters means that this one's digit right here is estimated. So it might be close to a little, 1.6 centimeters. It could also be 2.4 centimeters and just round it to that number. So if you remember that lab we did, we sort of, the last digit was the one that was always estimated. So if you look at this number over here, the 2.000, that means that the thousandth of a centimeter, which is really, really, really small, that's like taking the tip of your pen and dividing it up to 100 pieces. Well, you'd almost have to cut something that's this accurate. You couldn't cut it with a scissors. You'd almost have to cut it with a laser. So in engineering, a number like this is much more expensive to make than a number like just regular 2 centimeters. So we have to look at what numbers are significant here, or what we consider very, very accurate. So I'm going to give you whole bunch of rules on this worksheet. Like the first one says that all non-zero digits are significant, which means this 2 here is in 2 centimeters. Well, that's not a zero, so that's a non-zero number, so that would be significant. Then it says in rule number 2, all final zeros to the right of a decimal would be significant. So if you look at this, these are the zeros that are after a decimal, so those would be significant. Well, you have all these rules here, and it just blows your mind. It takes forever to learn them. So I got sort of a trick here that might help you. Now, what I'm going to do is I'm going to draw a really, really, really horrible map of the United States of America. So here is Maine and New York and all that up there. Here's Florida, the big Florida. Here's Texas, and that goes up back to Washington. Here's Kentucky, somewhere right around in there. Okay, and on both sides of the United States, there's oceans. For instance, on the right-hand side, you have an ocean called the Atlantic Ocean, and the Atlantic Ocean begins with the letter A. And so does the word absent. Now we're going to keep that in mind, because if the decimal in the number is absent, we're going to start counting the significant digits on the right-hand side. Over here on the Pacific side, or the left-hand side, we have the Pacific Ocean. Pacific begins with the letter P, and so does the word present. And so if the decimal is present, we're going to start counting numbers on the left-hand side. So let me give you a great example of this. I'm going to start looking right up here. And the first rule said, okay, what about 2.345 meters? Okay. Well, you just look and say, oh my gosh, there's a decimal in that number right there. Well, if there's a decimal in that number, that means it's present. So we're going to start counting on the left-hand side. And what you count is you just look for the first non-zero digit. Well, do you see how this 2 is a non-zero digit? So you just start counting at that 2, and you start counting numbers. So it's 1, 2, 3, 4. So that means this has 4 significant digits. Or they also call them significant figures. So if I say sigfigs or sigdigs, you know what I'm talking about. Okay, well, let's do a different type of problem. Let's say the number is, I don't know, let's say 400. There's no decimal. So the decimal is absent. So what I'm going to do is I'm going to start counting on the right-hand side. See where it says absent? I'm going to do on the right-hand side up here. Well, you start counting at the first non-zero number. So I'm going to start on the right. You start on the right. At the first non-zero number. Well, the first non-zero, well, let's see here. That's a 0, so that's a non-zero number. So here we go. I'm going to start right there at the 4. The 4 is my first non-zero number. and I started counting from the right. So therefore, there is only one sig fig. So I'm going to do some practice problems here. I'm just going to let you try one on your own without me saying anything. If you need to stop the video, feel free to do that, because maybe I won't stop long enough. But let me just see if I can write down a weird number here. Let's see, let's pick this. How about 0.00038? It's the same one as this one right here, okay? Well, the first thing you have to ask yourself is that decimal present? So if you notice, you'll see that it is, so it's right there. Well, if it's present, you got to look. Present begins with P, and so does the word Pacific. So you're going to start on the Pacific side, or what we call the left-hand side of the number. And then we're going to start counting at the first non-zero number. So the left is over here. Well, all of these are zeros, so we don't count those, right? So I'm not going to count those. Well, the first non-zero number is 3. 8's a non-zero, so therefore I just start counting. At the first non-zero number, you start counting, so therefore you have 2 sig figs. Okay, now let's do another one here. I'm going to give you 430. First question you ask yourself is that decimal present? There's no decimal, so you start saying it's absent, which means it's on the Atlantic side, which is the right-hand side. So I'm going to start counting from the right, and as soon as I get to a non-zero number, I start counting. So daggone it, that first digit is on the right is a 0, so I don't count that one. But that 3 is a non-zero, so as soon as you get to the non-zero, you start counting. So 1, 2, I got 2 sig figs. All right. So now you can do 1 through 16 on that worksheet if you pretty well just follow that. Now what we're going to have to do is we got to apply this to rules when you're adding and subtracting. Okay, so let's look at adding and subtracting here. I'm just going to add some numbers together. And the rule is if when adding or subtracting, the answer has to have the same amount of decimal places as the number that has the least decimal places, or the least accurate. So let's say if I'm going to, well, if I can get this in the right, let's say if I got 4.20 plus 5.1. Well, I'm going to have the answer would be 9.30. But that last 0 that you wrote down there, you can't put that down because the 5.1 is the number that has the least amount of decimals. It has 1 decimal place, where the 4.20 has 2 decimal places. So your answer has to be changed, and your answer is actually going to be 9.3. So let me subtract 1 here and do sort of the same thing. If I started out with, I don't know, 10.0000, and I subtracted 5.0, I would get 5. 10 minus 5 is 5. But my answer has to have the same amount of decimal places as the number that has the least number of decimal places. Well, if you notice, this 5.0 only has 1 decimal place, where the 10 has 4. So that means my answer has to have 1 decimal place. So I'm going to put in 5.0, and that would be my answer. Okay. Okay, lastly but not leastly, when multiplying or dividing, the answer's number of significant figures equals the number of sig figs in the number that has the least significant figures. This is so just confusing even to try to read it. So let me give you that. So let's say 6.00 times 2.0. Well, if you look at the number of significant figures here, this one has 3 and 2.0 has 2. Well, the answer you're going to get, the answer we're going to get here is 12.00, let's say. Well, your answer can only have two significant figures because your answer has to have the same number of significant digits as the number that has the least. Well, 2.0 has the least significant digits because it has two. Well, in order to make 12.00 have only two significant digits, we can use the 1 and we can use the 2, but we can't put the 0.00 down. So therefore, you start counting. Once again, the decimal's present. You start counting from the Pacific side, and it's just the answer is going to be 12. Okay. Well, let's say we divided something. Sorry about that. Let's say we divided a number like 10 divided by 5.000. All right. Well, the number 10, since there's no decimal, you start counting from the first non-zero number on the Atlantic side. So I can't count the 0, I count the 1. So it has one significant digit. 5.000 has four significant digits. Well, that means my answer can only have one significant digit. So 10 divided by 5 is 2. Whoops. 10 divided by 5 is 2. So I got to leave it at 2. Right? So that's where you got to be a little bit careful here. And let me give you one more here. Let's see if I can think of one that's a hard one to do. Okay, I'm going to do a hard one right now. I'm going to have this number 100 divided by 25. That's not what I want to do. Hold on. Okay, I'm going to switch this number here. I'm going to take 100 divided by 3. Okay, 100 divided by 3. Where do my pens go here? Well, the answer I'm going to get is like 33.3333, right? Well, here's the problem with that. 100 only has one significant digit. 3 only has one significant digit. My answer is 33. So you have to round this down to where you only have one significant digit. Well, watch what I'm going to do. I'm going to put a 3 because that's the one significant digit. And then the next one has to be a 0 without the decimal. Because if there was a decimal, there would be two significant digits. So now the answer is just, the answer is just 30, has one significant digit, and that's 100 divided by 3. So they can get pretty difficult here. So now you can do, if you practice these a little bit, you can do 17 through 30 on that worksheet. Hope this helps. Have a great day. Bye.